So we're picking up with part 3 of 5.1 quadratic functions, and we're starting this video with a try it, which means it's your turn. We had just talked about how to find the vertex when a quadratic function is in general form, and then use that to write it in standard form or vertex form. So that's what I want you to do here. I want you to find the vertex and then write this general form equation, which is not really in general form. Let's go ahead and write it in general form before you start. General form, it is in general form, it's just rearranged. All right, there we go. So x squared minus 6x plus 13 is our g of x. So take that in general form and convert it to vertex form, which is standard form. Okay, so pause the video, do that, come back, we'll go over it. Okay, so hopefully you have done what I've asked. You paused the video and then you worked the problem out. So remember, general form is ax squared plus bx plus c. So hopefully that can help you to see that a is the number in front of x squared, which in this case is 1. B is the number in front of x, which is negative 6. And c is your constant, which is 13. So to write or to convert a general form equation into standard form, we're going to start by finding h and k. So first, let's just talk about what standard form is. Standard form is y equals a times x minus h squared plus k. So we're going to start by identifying the h and the k. So luckily, we know a formula for h, which is negative b over 2a. So I'm going to do that formula, negative b over 2a, and I'm going to substitute in for b, negative 6, and for a, 1. So that becomes negative 6 becomes positive 6 over 2, which is 3. So now that we have 3, that's our h, we can substitute that into the function. We're going to find the function at h, and h is really 3. So we're going to redo the function, which was x squared minus 6x plus 13. And we're going to sub in 3 everywhere we saw an x, and we're going to simplify. So that becomes 9 minus 18 plus 13. 9 minus 18 is negative 9, plus 13 is 4. So this was k, we were finding k. So k equals 4. So the vertex is the point h, which is 3, k, which is 4. So going back to vertex form or standard form, we have y equals a times x minus h squared plus k. So let's start by subbing in our h. I didn't mean to do that. Our h and our k. And so we get y equals a times x minus h squared plus k. And h was 3 and k was 4. We actually also know a was 1, so we can just leave it, x minus 3 squared plus 4. Alright, so now let's talk about finding the domain and range of quadratic functions. So the domain of any quadratic function is all real numbers. Okay, so anytime you have a parabola, a quadratic function, the domain is going to be from negative infinity to positive infinity, which is the same as all real numbers. Unless the context of the function presents some restrictions. So the range of the quadratic function, it basically, okay, so if it opens up, this is a minimum, so the range goes from the y-coordinate of the vertex, which is, there's that little formula, from k up to infinity. Now, if it opens down, that means that the range goes from negative infinity to k. And again, k is negative b over 2a. So now we're going to find the domain and range of a quadratic function. So again, determine whether a is positive or negative. If it's positive, the parabola opens up and has a minimum. And if it's negative, the parabola opens down and has a maximum. Okay, this is a that we're referring to here. Now, once we determine that max or min of the parabola, which is k, then we can do the domain as I stated. It's either k to infinity or negative infinity to k, depending on whether it opens up or opens down. So here we're going to find the domain of negative x squared plus 4x plus 3. We can see that this is a quadratic, so the domain is all real numbers, so negative infinity to positive infinity. But the range, all right, so this one, sometimes I think it helps to draw it out. Now, I'm not drawing the accurate sketch, but I'm drawing the shape. And I know that because a is negative, it opens down, which means I have a maximum, which means my range is going to go from negative infinity up to k. So my range in this case is from negative infinity to k, so we need to figure out what k is. So in order to find k, we first find h, because we use h to find k. So we need to find our a, our b, and our c first. So a is negative 1, b is 4, c is 3. So h is negative b over 2a, which is negative 4 over 2 times negative 1. So it's negative 4 over negative 2, which is 2. And then k, we're going to substitute this 2 back in to the function. So negative 2 squared plus 4 times 2 plus 3. And we're going to put in 2. And that's negative 4. 2 squared is 4. Bring down the negative. 4 times 2 is 8 plus 3. So negative 4 and 8 is 4 plus 3 is 7. So k equals 7. So for the range is going to go from negative infinity to 7. And the k should have a bracket with it always. All right, so you guys, you try this one. This one, you're still finding the domain and range. This one is in vertex form, so this might make it a little bit easier. Hint, hint there. So pause the video, and when you come back, we'll go over the answer. Okay, hopefully you found the domain and the range of this quadratic function. So it's a quadratic. So the domain is all real numbers. The range. Okay, so let's locate A. A is positive, which means it opens up. If it opens up, that means I have a minimum. If I have a minimum, I'm going to go from negative, I'm saying that wrong. I'm going to go from the minimum, which is k, and I'm going to go up to positive infinity. So from k to infinity. So I need to find out what k is. But luckily, this is vertex form. And look, there's k right there. So hopefully you recognize that. So it goes from 8 over 11 to infinity. Hooray. That was easy. Okay, so now we're going to determine the max and min values of quadratic functions. So the minimum value is a vertex. The maximum value is a vertex. So for this function, whether they give you the function as an equation or whether they give you the graph, you can identify the minimum. So the minimum is the vertex, the k of the vertex, the y-coordinate of the vertex. So in this case, it's 1. So the lowest point on the graph is at 1, and that occurs when x equals 2. If you're looking at the equation, find the k. So if it's in vertex form, you can easily identify that. If it's in general form, you're going to have to figure out what the vertex k is, and then that would be your minimum. And the same thing, it's also your max if it opens down. So this is negative, it opens down, so this is a max. The max is 4. You can see it in both places there when x equals negative 3. Okay, so let's look at this word problem. Find the dimensions of a rectangular corral producing the greatest enclosed area given 200 feet of fencing. So if we had 200 feet of fencing, what would be the dimensions of the rectangle, because the corral is rectangular, that would give us the greatest area. So what do we know about area? Area is length times width. Okay, and we want to find when that's the greatest, the area is the greatest. So we're going to write an equation for area. But we have two different variables here. We want to get it down to 1 on that one side. So let's see what else we know. We know that if we had to label this rectangle, the longest side, those are the lengths, and then the widths. And then if we added them all together, that's the perimeter. So L plus L would be 2L, plus W would be 2W. So 2L plus 2W equals the perimeter, which would be 200 feet of fencing. So again, we need to get this in terms of only one variable, either L or W. So what I'm going to do is I'm going to solve for W, and that way I can write the area function in terms of just L. So if I want W by itself, I would subtract 2L from both sides, and I would get 2W is equal to 200 minus 2L, or negative 2L plus 200, and then I would divide everything by 2. So W equals 100 minus L, because I'm dividing 200 into, I'm dividing 2 into 200, and I'm dividing 2 into 2L. So 100 minus L, or negative L plus 100. So then I'm going to go over here, and area is length times width, and width is really negative L plus 100. And I want to simplify this, so I'm going to distribute this L to both terms, and I end up with area is equal to negative L squared plus 100L. And here we go. We have a quadratic, and I know that it opens down because of that negative right there. It's going to open down. And this graph that I just sketched, it represents the area. It's the area. And so where's the maximum area? It's right there on the graph. That's where the maximum area is. And we need to find the dimensions there. So we need to find that vertex for that that maximum point. So vertex, if you will recall, is HK, and H is negative B over 2A. Now we need to figure out what A and B are. So A is the number in front of L squared, which is negative 1, and B is the number in front of L, which is 100. You just treat the L's like they're X's. So negative B over 2A, and B we said was 100, and A was negative 1. So we have negative 100 over negative 2, which is 50. So H is 50. H is really the L coordinate of the vertex. So L is the length. So the length is 50. Now, if I go and substitute 50 in here for the width, or into the width equation, we get W equals negative 50 plus 100, which is also 50. So the maximum area is 2,500, and the dimensions are 50 feet in length and 50 feet in width would give us the maximum area of 2,500 square feet. Okay, so we're going to pick up with part 4 in the next video.